All right. So the rule of majority has been imposed that if there is no majority, there cannot be an election. Nobody can be elected as a leader. So right now, this side is 5, this side is 5. None of them is a majority. Majority means little bigger than 50%, okay? Little bigger than 50%. So now this section is in majority, you see? 3 plus 3, 6 and 7. Or this section is still in majority. So Leonid, yes, one is selected as leader, thus need to have at least 5 votes. Yeah. So howsoever you do the counting, the main reason to have majority is to have more than 50% people voting in the election. Okay. If less than 50% of people have come to the election, then this democracy is under a threat because the rest of the people might be voting for somebody else. Okay, and they might be electing some another leader. Okay, so when we say partition means the network got partitioned, the connection between the network is shut down. Okay, all right. Now, I mean, this diagram, which is what I was showing you, let's say there were two data centers, ABC and ABC. Now, between these data centers, if the connection goes down and both sides elect their own leader, then there will be a major problem, right? If there are two leaders, they both are claiming to accept the same data, they both are accepting the same changes, then one user goes to leader A for first time and then will go to the B because the client or whosoever is the client library will retain a pointer to these leaders data, right? So pointer to point, it will retain pointer to A and D both. Okay, the client library. And in case the in case there become two leaders, so user might write here and will try to read from here, which will never reach, right? And therefore the whole data gets corrupted. All right, that's why we need majority. So if there had been a rule that only majority people can vote here, then since 3 is not majority out of 6, because 4 is majority the way we define is more than 50%. Okay, Matthew, now it makes sense to you? So who decides how many nodes are there? It is up to us. We own the data center. We are setting up Zookeeper. So what we want to do is we will add all these nodes and then start the cluster. All right. What we can do is, let's say we are left with 5 nodes. Okay. We are left with 5 nodes. Then we shut down the cluster and then tell that we only have 5 nodes. We only have 5 nodes out of 10, then we will only start the cluster with 5 nodes. Now, the objective is that the administrator knows that there are these many nodes left, and therefore, there cannot be any other confusion. Now, Matthew's question is, but how do we know how many nodes we require? So it all depends on how much data do we need to read, or at what rate we want to read. If we are getting something like 50 requests per second, in a second, if we are getting 50 requests and the data retrieval is taking time, okay, so for 50 requests, a system with a single machine is good enough, okay, or maybe two machines are good enough. But as the request goes it up to 10,000, you will have to have a bigger cluster. So the more number of requests are coming per second, the more number of nodes you will have to keep, okay. So in no matter how, say here it is. So as and when more and more clients keep coming, we'll have to keep adding more and more machines into the Zookeeper ensemble. Yes, so 10 is a lot of nodes. All right. But, so when we talk about 10 nodes, right, in case of Zookeeper, it'll after some time it actually becomes less because Zookeeper, a service like Zookeeper will be used by lot many services than we think of. Okay, imagine that is being accessed by all the data nodes and all the name nodes in your cluster. Name nodes, data nodes, HBase master, region server, and there are lots of services who will use your Zookeeper. So your workload will keep on increasing, and as and when your workload is crossing a certain limit, and you observe that your CPU and RAM is really high of those two machines, a few machines which you have set up in Zookeeper, then you can increase that. All right, great. So that was a big discussion about how many number of nodes you require in a Zookeeper cluster. Second part we already discussed in detail was that why do we require majority and what does it mean by majority. All right. So Leonid's question is Zookeeper normally installed on data nodes? Normally in a larger organization, we install Zookeeper on a separate cluster. If your Zookeeper start getting overloaded, people move Zookeeper out. But but we should be avoiding installing Zookeeper on name node, okay? Because name node requires a lot of memory. And similarly, Zookeeper also requires memory. Therefore, it's okay to keep Zookeeper on data nodes. All right. So these are the consistency, the guarantees we talked about: the atomicity, single sequential consistency, and durability, single system image, and timeliness. All right. A client has a list of server in a sessions. A client has a list of server in in the ensemble. It tries, so the way a protocol works is the client, as in your application can be the client, and the actual true client for Zookeeper is the library provided by Zookeeper through which your program will talk to Zookeeper. Okay, that's called Zookeeper client library. You are client, but you are the user of Zookeeper. Okay, so the client library or the client has list of server and the ensemble. It keep on trying until it is successful. So if you have 10 nodes in the cluster, you inform the client library that these are the 10 nodes. Okay. Even if you add lesser number of nodes in the client library, you inform, although you have 10 nodes, but you inform about 2 to 3 nodes to the client library, still it will automatically discover. All right. So it keeps trying until successful. And a session has a timeout period, and that is decided by the caller. If the server hasn't received the request within the timeout, it may expire the session. Okay. So what happens is that every time a client comes in, it creates a session, and each session has a timeout period. If the session has not been pinged by the client, if the client does not respond for some time, for server assumes it to be dead. Okay. After a timeout period, server assumes it to be dead. That's how it keeps the list of nodes fresh, meaning these are the only uh, clients available at this point of time. And as soon as connections are lost, the ephemeral nodes created by that particular client will get deleted. So, so the client library, the library which your program will be using, will keep on sending heartbeats. Okay. Now this client library's duties that sending heartbeats, doing all of this mechanics, you don't have to worry about that part. And failover is handled by the client. Sessions are still valid on switching to another server. And the applications cannot remain agnostic over server reconnection because the ops will fail during disconnection. Meaning, if you are writing a software which connects to Zookeeper, your program cannot remain agnostic to connection failures. Okay, meaning your program has to do a try catch in the situation of connecting to the Zookeeper and all that. So your program should be doing kind of a try 3 times kind of logic. Okay. Now there's a question from Matthew. What are the differences in the role of Yarn and Zookeeper? So Zookeeper is so Yarn is a kind of a operating system kind of thing where it gives you resources and gets your code executed on various node managers. Okay, it manages the resources like this one is free, that one is free, all that. So this is Yarn is for this. Okay, and it's the map reduce kind of applications which use Yarn, or basically they have written applications which run on Yarn. Okay. While in case of a zookeeper, we have it is for coordination between many to many users. All right. Make sense to you, Matthew? So so let's say you want to get something done on all the nodes. Okay. In those cases, you use You will have to either get aligned with MapReduce, or you might want to go ahead and write your own framework like MapReduce. Okay, if you are writing a framework like MapReduce, Apache Spark, and Giraffe, for example, you will use Yarn. All right. So now there is a question. So Zookeeper directly communicates with Yarn. It's the other way. Okay. Yarn communicates with Zookeeper. Okay. Why? Because if name node, so the way it happens is that when we put it in high availability mode, let's say when a system is kept in high availability mode, all the data nodes ask Zookeeper, who is our current name node. Okay. All right. So whether it should be secondary or it should be name node, if you are keeping a backup of name node and there is some secondary name node. So in high availability mode, all the data nodes will give will ask Zookeeper who is our name node. Okay. But before that, name node one will inform Zookeeper, okay, that uh, okay, will by creating ephemeral node, create ephemeral node of my IP as data. Okay. Now secondary name node will also do the same thing. So now when data nodes ask, let's say data node 1, data node 2, and so on, when they ask Zookeeper, all it has to do is it has to give the list of ephemeral nodes right away. Now, now if name node goes down, this ephemeral node will disappear and there will be only one server listed. So data node will know that this is the only one which is available right now. All right? Do you get it? Now, question is again, let me repeat. So, does Zookeeper communicate directly with Yarn? So, as you can see that these the way name node and data node were communicating in the same fashion, the what do you call the node manager, and resource manager. These are the components of Yarn. They also communicate with Zookeeper. Okay. They also communicate with Zookeeper to get the status of task track. How many? So resource manager would like to know how many node managers are there, and vice versa. So this discovery happens through Zookeeper. So Zookeeper does not depend on either Yarn or anything else. Make sense, Matthew? All right. Like all of this is shown in these diagrams. So this is how the connectivity happens, and this is being shown in these diagrams. So on left hand side you have a lot of servers, and on right hand side you have the clients. If these clients have to if all of these clients have to keep checking which server is available, keep pinging these servers, that will not be good. Instead instead you generally use Zookeeper in between as a layer of code for coordination. So all these servers will inform their status to Zookeeper in the center, and on the right hand side all of these clients will ask Zookeeper that which server should we connect. All right. when asking zookeeper means give me the list of all the folders. Like here the this machine connected to the host, and it created this particular server, and again it created duck and cow. Now if the so all these servers are coming up. First, Duck has created its ephemeral node, then Cow has created ephemeral node. Now, when the client comes in and asks the zookeeper that give me the list of servers, meaning ls slash servers, it will return ducks, comma cow. Okay, give me the list of all the nodes under the node called servers. So it will give duck and cow. And after some time, if duck server is down, so this ephemeral node will disappear, and there will be only one node under slash servers, which is cow. Okay, that's how it happens. So you can try this hands-on. We had already tried last time. You can try this hands-on. All right. So there are more use cases of Zookeeper for building the reliable configuration service because it's for small data, so configuration is good enough to be stored at Zookeeper. So if your program has certain part of configuration which need to be really well available and need to be reliable, in those cases you go for Zookeeper for that part of service. For that piece of data, you generally store it on Zookeeper. It can be acted as distributed lock, as we started with an example that if you have to keep a lock on emails or you have to divide the work, then you can use Zookeeper. And yeah, and also since because the it can be acted as distributed lock service because only one process can hold the lock at one time. All right. Now, there are few things you have to keep in mind when not to, although Zookeeper looks like a database, Zookeeper looks like a hierarchical database to lots of people, but if you look at design, it's not suitable to store really big data because number of copies of the data will be equal to number of the nodes. Okay? And because of these two reasons, okay? Okay. Now that was one. Let me just put one more thing. And number of copies are equal to number of nodes. And second reason for not to store big data is because all data is loaded in RAM 2. Okay. Second, when not to use Zookeeper is when you want extremely strong consistency. So although the consistency is really good in case of Zookeeper, but still the the downside of using Zookeeper is that the still whenever we are writing the data, as soon as the data goes into majority, as in the total number of copies written to the disk are more than half, then as soon as that happens, it gives the confirmation to the end user. But that doesn't mean that the user's request is not going to those minority servers which are not yet updated. Okay. Now there's a question. Let me have a look. What does it mean? All right, all right. You can ignore this part, yeah. You can ignore this part. So that was the question from Leonid. All right. All right. So that was our zookeeper. So although we have eventual consistency and majority consistency, meaning the zookeeper will give you the confirmation if some number of nodes have stored the data, not only one node, but some number of nodes. And that some number is majority, meaning more than 50% nodes. So, yeah. Matthew's question is Hadoop developers mainly need to know how to manage many nodes, how many nodes are needed. I think that's what you need. Is that your question? Yes. So yes, that's a primary role. That's a primary role. Basically, I would say that they mainly need to know. They mainly need to know when problem cannot be solved using single node, single machine in a traditional sense, and if not, as in if, uh, and how many machines are required, how, and how would the problem be solved using multiple machines. Okay. If it's a batch-wise computation, you might want to break down into MapReduce. If it's just a storage problem, you might like to use it uh, something like HBase or something. And if it's huge if it's related to related to just analyzing really big file, then you can use Pig or Hive and those kind of decisions. So those decisions start to be taken by Hadoop developers. That which tools to use in what circumstances. Okay. Did I make sense, Matthew? So they need a Hadoop developer has to clearly identify that okay, this problem cannot be solved using single machine, and we need to have more machine in the network. And if we have more machine, then what is it that we are going to put on those to solve our problem? So, Matthew's question is, shouldn't we use more than one node in case the node goes down. Of course, we know that's what the discussion was here, na? That what the discussion was in Zookeeper, right? So yes, we should use, and that's what we discussed in this, as in, and if there are so it's like this. We realize that our node goes down, okay, and therefore we need two machines, more than one machine. Now, who keeps the data, who writes to the data, and who reads from data? And that's where the elections come into play, that one of those nodes will automatically get elected. Now when elections come into play, there are challenges like, what if two nodes become the leader? In those cases, the majority rule came into play. So all of that is the understanding a Hadoop developer need to build. Okay, because all the challenges of, say, the moment we go from single machine to multiple machine, the whole idea of computing changes. Okay, your normal program, if you have been doing a traditional programming, you'll have to start thinking in terms of map reduce. If you have been doing a traditional database management, then you have to stop thinking in terms of your uh, schemas and all of that. Instead, you need to start thinking about elections. Okay, elections and the consistencies and eventual consistencies and all that. All right. So did you mean that on? I mean, yeah. Did I make sense, Matthew? So this more than one node is the reason why we are doing all of this. So these are multiple nodes this side. These are multiple nodes this side. Okay. So these are all six nodes on which Zookeeper is installed, and we are trying to connect. All right. All right. Any other questions at this point? All right. Let me just put Matthew's point here. Yes. So yes, I asked because you said we had to know when to use. Oh, yes. Correct. Correct. Yes, it does make sense. You're correct. Because it's probably the most important thing for a Hadoop developer or any developer as of today, to know that it's not that it's basically quite difficult to get things done on a single node. Okay. All right. All right. So moving on to the next session. All right. Should we start the next session now? So we just finished a very important part called Zookeeper, and Zookeeper is heavily load balanced, as in lots of nodes and really well automatic. So once you start a Zookeeper cluster, it automatically keeps deciding internally. Okay, so you don't have to keep shutting down, starting up, and all that. Okay. All right. So should we start Zookeeper this Flume, Scoop, and Mahat discussion today? Now, Vaibhav, Matthew, Leonid, John, Deepak. All right, great. Great. So there we go. So these tools are quite simple, Flume and Scoop. Let's talk about Scoop. Scoop is a very simple command line tool which help you import the data from MySQL or any other database into your big data, your Hadoop infrastructure, from RDBMS to Hadoop infrastructure and Hadoop infrastructure to RDBMS. Okay. So on one hand, we have, in case of Scoop, on one hand you have these relational databases such as MySQL, MSSQL, and all that, and on other hand you have HDFS, Hive, and HBase. Okay, so we'll just do a hands-on, and that will make more sense to you than the theory part. So a scoop is to extract data from structured data sources such as normal databases or maybe MongoDB into Hadoop for further processing. It can also move data from database to HBase directly and vice versa, and it can also do the reverse. Now, now if you had to, okay, let me ask you this. Let me ask you this. If so, based on your knowledge so far, if you have to copy the data from MySQL to say a file in HDFS, say CSV file in HDFS, okay, what would you do? So we have discussed about MapReduce processes and all that. And if I ask you that you have to import data from really highly efficient MySQL, you have this powerful machine which is serving your MySQL data, and you want to copy the data from this MySQL to HDFS. Okay, what will you do? Any idea? Just give me any ideas. Without scoop, of course. Okay. Leonid says save the result of query into delimited file and copy it to HDFS. Brilliant, brilliant. And the same thing Matthew is also saying. Put that in CSV file, okay, and upload it to the Hue. Good, good. Now let me take it further. Let me go take a step further. All right. Now, will that be a great way to get it done? Or let's imagine that it's around 1 TB of data. Let me put, so Matthew's adding to his point that, or get it compressed and apply. Yeah. So that's a good answer. That's a good answer, that we can export the data to a CSV file and then upload it. Now imagine if you have 1 TB data. 1 TB data and your HDFS is running on 10 machines. Okay. All right. So, okay. Can't we utilize these all 10 machines to directly copy the data from MySQL? We have 10 machines running and we have 1 TB data to be copied from MySQL. So, so can we utilize these 10 machines parallelly to copy the data directly from MySQL? So Matthew's point is, can Hive do that? Hive can't do that. Anybody? Can anybody suggest a strategy that can we can we utilize all these 10 machines? Hint, can we do a map reduce? Leonid is saying that we can use a batching tool, active batch, okay, interesting, to send command to each. Okay, Matthew says, I'm sure you can. Good. Good. So Weber is saying very good point. MapReduce will first need the file in HDFS before it can act on it. That's correct. That's correct. So that's where the trickiness starts. Okay. So you basically create a file with some numbers in it, 1, 2, 3, 4, 5, 6, and that's what is made available to your program. And then you enforce MapReduce. You force MapReduce to run multiple mappers even if your data is smaller, so that one record goes to one mapper. All right, that's what Scoop does. So although it's not a big rocket science to build your own MapReduce program which imports data from MySQL, but making such a program is little time consuming. Good, very good. Now let me move ahead and show you. So that's what Scoop does. Scoop talks to MySQL via MapReduce. So if we say scoop import, all it's going to do is create a MapReduce process where mappers are running on 10, 15 nodes, whatever nodes you have, and is pulling the data from the remote onto this machine. Okay, so let's get hands on. And also there is an idea of a connectors, which means that you can create your own connector for Scoop, although you will never need to have, because anything which is compatible with RDBMS or any database which has got an interface of JDBC, which is Java Database Connectivity, or ODBC, if any database has such a driver, then it can be used with the connector. All right, let's try a sample import. Okay, let's try a sample import so we will understand how the things go. Sorry. Let me check Ambari. Looks like our name node is in safe mode. So let me just try to bring name node up. So when I try to copy a file from local machine, which is B1, and to asgiri b to asgiri b1, it says that cannot create this file because name node is in safe mode. And let me just go back if we can solve this quickly. Let me just try to increase. Actually, we are upgrading the servers. That's the reason. So we have just doubled the capacity of the cluster. If you can see that. So all right. If you have any questions till then, I can discuss. It might take a little bit of time. Or what we could do is we can go ahead with our discussion on um, our discussion on Spark, and we can take care of the rest of it tomorrow or something. Again, yeah. So Leonid's question is, it appears that managing Hadoop cluster is pretty involved process and requires more effort than managing for no. Okay. It just seems because right now we are just two, three people who are trying to manage this cluster. That's the reason. Okay. While in case of when I talk to people at say InMobi, my ex-employee, because those are when I talk to admins of InMobi, what they were saying is that setting up a cluster takes a little bit of effort, but in today's time in Ambari and all, it sets up quickly. And once you set it up, it keeps running silently. It keeps running silently. Okay. Okay. So this seems to be a myth because of right now also we are not devoting too much time on this. Okay. That's why you might feel that way. I would say that it's not a problem with Hadoop and all. People who have say at in Mobi we had around 700 nodes running for the analysis part. Okay. And they were able to effectively manage most of their data and handle it. Okay. So given the complexity of operations, the handling of HDFS or Hadoop was absolutely seamless. Okay. So most of the admins were able to focus on physical hardware, as in these many hard disks have to be replaced, and most of the they were able to focus on that while the data was managed by HDFS. That's the feedback I have got from many people, that once you set up HDFS properly with proper disk, it keeps running. It just keeps running. Now Matthew's question is okay. Matthew's question is Ambari used on all commercial distributions of Hadoop, or there? No, the Ambari is used for commercial. Yes. So Ambari is used for commercial distribution. There's no issues at all. Okay. All right. Let me see what is happening. All right. So this code is okay, and dashboard. Let me check the memory. So this much is disk used. So memory is okay. There is no problem at all. All right. We'll look into everything else later. In our case, we are trying to run every service, and that's the problem. Ideally, we should have more different networks to run all the services differently. All right, let me just try copying it again. Yeah, it's working now. All right, all right. Then so let's start with creating the database here. Okay, so all right, now here, so we what we are trying to do is right now we are connected to our usual database, which is MySQL here. So we are connected to a relational database. Okay, and I've already prepared this data. And why are we doing this? So that we can prepare some dummy data in MySQL, which we will copy from here to a remote machine. Okay, to Hadoop we will copy from this MySQL. So also keep in mind this thing very clearly. If you are running your normal import, let's say this one, okay, you will be very happy on a single machine that it worked. But the problem occurs when you start doing it over a Hadoop cluster which is having multiple machines. And why? Because by default, MySQL does not allow you to copy or access data from remote unless you change the permissions. You have to grant permissions to various hosts, and or you have to make the database itself sort of public to all. You have to grant permission to all the hosts. Okay, so keep that in mind, that your database has to be given permission so that all the data nodes, or all the node managers can connect to your MySQL or MS SQL. Because as opposed to the common sense that we are just copying from here to there, here we are scheduling a copying, and those nodes will be connecting back to MySQL and then copy the data, which means there will be requests to MySQL coming from multiple machines simultaneously, and therefore those machines need to be given the permissions. Okay, this is the classic case where the things which run great locally work great, do not work on the cluster. So this is one classic case where when you run things on local machine and in the inside the virtual machine, everything will just work. But when you take the same script and put it on the production machine, nothing will work, and you will say that there is something wrong with the cluster. Okay, all right, good questions. Now let me just copy Leonid's question. Very good, very good. All right. So Leonid's question is that wouldn't there be a security issue? For example, if the user has access to the machine, they can connect to MySQL from that machine and load the data manually. No, you are giving permission to host as well as the user. Okay. Here, this kind of thing, what we are doing, this is not what you're going to do. Instead, you're going to say this particular user at a host name. Okay. So, howsoever, you just have to make sure there are many ways of giving the permissions. Okay. You just have to do that. That's all. Okay. In case of MySQL, generally any seasoned um, uh, administrator will anyway create a database with the permission so that it can be connected from remote. Okay, but if you just create a normal database which was being accessed locally by on the same machine by a web server or by a scripts, that may not be accessible right away. Okay, it's a common practice to just hide the database on local machine, but the moment you go into production, you have to make it visible to the network. Password protection will always be there anyway, Leonid. Okay, so all right, I hope the guy gave the answer. Yes, so Webber's point is that if we have so many nodes, we could simply give the privilege like this. That's correct. I think here it is to be something like percentage, I believe. Yeah, yeah, like this. If you see, like this. I think this was sufficient. I have just given all kinds of examples. This was sufficient. Uh, so Matthew's point is that don't we require password in while using? Yes, we require password. We require password. Okay. All right. So the database we are creating, we are just creating a dummy table called create widgets. In that widgets table, we are adding 3 rows. Okay. So at the end of it, you will see select star from widgets. So there will be these 3 records. Now we have to take it to the HDFS. All right. We have to take this to HDFS. Okay. So here we have right now the password I have reset it to blank for this session. Okay. So I created this sample file. I first created the database, made the database accessible to all the nodes, all the Hadoop nodes, created the table, put some sample data into it. Now we are saying scoop, import this particular table, this particular database, and this particular table into our HDFS. Okay. Import means taking data from MySQL or other external database to HDFS. Okay, let me open one more terminal. Let me just connect to Hadoop 2 dot student at Hadoop 2 dot no big data. All right, so I'm right now connected and is starting to copy the data. Let's see what happens. Okay, okay, so it's running the job. You can see that it's running the MapReduce job, and it has copied the data successfully. There you can see Hadoop fs minus ls widgets. Under the widgets, you can see that it's created just now, and you can see here Hadoop fs minus cat part m0. You see m here? M means the data from mappers have directly gone into the HDFS. There is no reducer involved. Okay. Had it been R, as in our case, you remember our example of uh, sgiri word count output. So there, uh, so let me just say output November. I'll output this one. Where is that? Now in the our usual word count example, the output file you see it has R instead of M. That means the data which is stored into this file was being stored by reduced surface. In our case, which we just did here, it is M. M means our there was no reducer. Data directly went from mapper to the HDFS. Okay. Now if you see here, we have been successfully able to copy the data from MySQL into this particular file on HDFS. Okay. For this kind of data, so this kind of data where you have only 3-4 records, you can easily copy it using exporting to CSV and then copying the data using Hadoop copy from local. Okay. But in lots of cases, that's not recommended because you are not really utilizing all your nodes. All right. So I hope that's clear now to everyone. So whatever table name was there inside this database, that table name, with the same table name, a folder is created. Also, you can specify the exact name of the folder while running Scoop. All right. All right. Good. So this came to from normal till HDFS. Now we will try to do it into Hive. Okay, Matthew. So we were successfully able to copy the data into this. The next step would be that sometimes we want to put the data into Hive. One easier way would be to basically load the data into Hive. But before that, so we have already copied the data into HDFS, right? We can simply load the data into widgets. But for that, but to do that, we'll have to create this table called widget into Hive as well, right? We'll have to create this table widgets into Hive as well, right? Therefore, we'll have to either do it manually or we can use a scoop command called create Hive table. Okay, we could use that. So we can say scoop create Hive table, right? So it has created a Hive table. It has created a Hive table for this. Okay, we can launch Hive and check if there is a table or not. So we are executing saying scoop create Hive table, connect to this database. For this table, fields are terminated by comma because this file which will be loading is comma separated by default, right? and then this is my login, that is my password. Okay, so we can say show tables widgets, show tables. Okay, now select star from widgets. Okay, the data is already there, so let me just delete from widgets, or drop table from widgets. Sorry, drop table called widgets. So I'm just deleting the table. So I've deleted the table. Let me re-import again. Let me recreate the table. So what does create Hive table does? It Scoop goes to MySQL, finds out the schema, and for the same schema, it creates a table in Hive. Okay, so that you don't have to do it manually. Okay, now if we see select star from widgets, let it come. Okay, right now there are no records, and this is where we have kept our data. So we can say load data from there to Hive. Okay, so the first we copied the data from HDFS, from MySQL to HDFS in CSV, then we loaded that into Hive. Make sense, Matthew, now? All right, so that's how we copy the data from in three steps. First we copied the data from MySQL to HDFS. Then we created a table in Hive and imported data by using load data. So these are three steps. If you want to do it in a single step, you could do it in a single step in this following manner. Okay, so let me just drop table widgets, and if you want to do it in a single step, you can do it in a single step. Here I'm saying here here I'm saying scoop import connect to my MySQL from here to there. This is my URL, and then the table called widgets, and here I'm using this command called hive import. Okay, this command called hive import, and that's it. So it says output directory already exists, right? Let me just delete that. How Hadoop fs rm r widgets. So I deleted the directory. Okay, so that's how you can import in a single shot. Here the password is blank. We have resetted the password to blank for this session so that there's no problem at all. So here see this is how it's copying. All right, so I hope this is very clear. The parameters like how many mappers do you want, and all right, so good. Matthew and Leonid both have exact same question. Matthew says when it went into HDFS, it was in CSV, and same as Leonid. Leonid says that is comma the delimiter. Good. So let's have a look at the table description. That should give you an idea. Describe formatted and widgets. That should tell you exactly what format is being used. Okay, so you can see that the location of the file is here in widgets in the warehouse, and it has been created. All right, now here you can see. All right, all right, so it says that these are the columns, this is the HDFS URL, and this is the table type. Okay, and here the field parameter, line delimiter are different. You can see that line delimiter is new line, while field is delimited by Unicode 001. Okay, if you don't believe me, you can have a look at Hadoop fs minus ls. This is where the underlying data is stored. You can see that it's not comma, it's some special character which is not visible right now. Right? Make sense, Matthew and Leonid? All right. So Weber's question is, there were two options. In first one, we created in if we imported file into HDFS and then created table in Hive and then loaded Hive table. Exactly. Yes. Second option was import into HDFS and then import into Hive in a single command. All of this into single command was done. Yes. So So Hive is doing import, comma, yes, Hive is doing all for that. Okay. So Hive is doing it for you. Yes. So basically the scoop command is launching the Hive command internally and then getting it done. Okay. Scoop is calling Hive to load the data, create the table and all of that instead of you doing it. Leonid, no, it's not comma. Slash U001 is not comma. You can see the comma anywhere. It's not comma. It's just some unprintable character. Now, Matthew's question is, so how can we import from MySQL as CSV for pig using our first strategy? Using our first strategy, this one. You remember? This is where what we did. So import the file using HDFS here. Okay, Matthew? Right. Yes, 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 that's correct. I'm sorry, Matthew, you are right. So this one, this import, normal import command is having the data comma separated, but the one which uses directly, the Hive import one, does not use the comma as the delimiter. Okay. Yeah, you're right. All right. So that was in a single shot. In case you want to copy data from HBase, to HBase from here, you can do it in a single shot. Also note here that what we are saying, scoop import connect to this database and with table these tables, and in HBase we want to create a table called customer, and we already have a customer table having a column family CF1, and okay, and in case required create HBase table as well. That's what it's saying. And here uh, the also you can say that in this column family these only these columns will be copied. Okay, this is what is happening here. Okay, let's take you through this one. All right, let me try to execute this. So there is no column found called A1. Okay, there was no column found called A1. You'll have to do it in two separate steps. So we are trying to copy the data from widgets, and let's just say widget name and ID. Widget name. Ouch. The HBase we had shut down. All right. Now, I think I should describe it little more. Let me describe it little more. What exactly are we doing here? Yes, that's correct. So Matthew has already described that. Yes, Matthew, you're right. So this was importing into HBase, and we can break it up into separate column family. Okay. So if you remember in MySQL you have proper tables, right? In HBase you have table which has got name and column family. Okay. No columns. You don't have columns in case of HBase table. Okay. By default you do not define. When we say table definition, it means the name of the table and the column families, but no columns. Okay. Now, whenever we are importing, these columns will be created automatically. Okay. Columns will be created when required. Okay. But which column family? Right? Because we talked about earlier that whenever we are adding a column into HBase, it has to go into a column family, and that's what is decided by this. So we can only import data in one shot into one single column family, and we can say that our data from widgets is going into a customer HBase table in this column family, and only these columns from our widgets table are going to go into this column family. Okay, if there are two column families, you can execute the same command again with different column names and different column family. Okay, sometimes also there was one more important requirement from HBase side, that what would become ID, right? Row ID or row key. So if you remember, in case of HBase, it is mandatory to have row key. So what would that become? By default, the row key is ID, and any column with the name ID is the row key. But you can also specify explicitly. Okay, you can also specify explicitly that this is going to be my row key. All right. All right. So Leonid's question is, are we creating table or are we just adding columns? It might create table if the table does not exist already. All right. Let me just see if it's coming up. All right. Let's try to do that again. And let's see what all errors occur. What's happening? Yeah, it's copying the data now. It's saying the. So what does it say? Cannot insert row with null value for row key and the column ID. All right, that is correct. So why is it happening that way? Could not insert row with the null value for the row key column ID. All right, let's just try to get it done. I hope that this time it'll run. All right, let's have a look at it. So we created this. We had to actually, I think, copy this, put ID column here as well. Okay, rest is okay. And what was the table name we are creating? We are creating a table name called customer. All right, let's have a look. So we say hbase shell, and it should have only these two column names: widget name and ID. Scan customer. All right, so you can see that. Okay, okay. So what do we call disable? I think the data was already there. We just inserted one more value to it. That's all. The data was already there. Okay. So disable table. What's the name? Customer. Okay, delete. All right. Leonid's question is, if widgets table if widgets table in MySQL has columns that need to be split into multiple column families. Good. Yes. So that's what I was saying. So if widgets table in MySQL has columns that need to be split into multiple columns, can we do that with one SQL command or two? So you'll have to do it using multiple SQL commands, multiple scoop commands. In first scoop command, in one single shot in scoop command, you can only copy the data to one column family. Okay. Let's see what happens this time. Let's have a look exactly. This is the command which we are using right now. Billion. Good questions. So we can say scan customer. Now you can see that it has only copied the data of widget this time. All right. Reason was that earlier I think uh, the other data was there. Okay. So here we were just copying ID, comma widgets. All right. I hope that's clear to you. Good, good. Let's take a break for 10 minutes and back by say 9 o'clock, 9 a.m. IST. And if you do not mind, I would like to, uh, you know, for some reason, I'm not able to mute this thing. It's sort of not responding. I'll have to exit the web meeting as in